In today's video, we are going to use SOH CAH TOA in examples. And let's just get straight into this example. So the first step is to label your graph. If you have not watched the video where we just broke down SOH CAH TOA, go check that out. I'm going to leave a link in the card. That video is super important in case if this is your first time hearing of the phrase SOH CAH TOA, or trigonometry, then you really want to watch that video because I'm not really going to go over the basics in this video. So here we have our triangle and we're asked to find theta. That's important what we're asked to find. We're asked to find theta. So the first step is to label. Again, this is going to be our hypotenuse because this is our longest side. We have our opposite and we have our adjacent. Now, after we're done labeling, we have to figure out what trig ratio we're going to use out of SOH CAH TOA. So we are given our adjacent and our hypotenuse. So the only one that we have to use right now is our CAH because it has adjacent and our hypotenuse. So we're going to use cos theta equals our adjacent is 8 over 11. Our hypotenuse is 11, so 8 over 11. And now we're going to find theta. And so in order to do this, we need theta to be alone. We need that angle to be alone. And so we're going to have theta equals cos -1 multiply 8 over 11. Whoa. That looks like, where did the -1 come from? Honestly, I couldn't really tell you. But just know that when you're finding theta, when you're finding the angle of the triangle, you're going to take the inverse of cos. You're going to take the inverse cos, that's what it's called. You're going to take the inverse and then you're going to multiply that with it, right? Because usually what you would do is probably maybe take away cos from both sides or something like that. But just know that this is how we're going to do it. We're going to grab our calculator, and on the calculator, you need to find your cos inverse. So cos with the -1 on the top. Don't use your regular cos. You want to use your cos with the -1 on the top. That way you can really, that's what you're supposed to use. So usually in most calculators, it usually is right at the top of your regular cos sign, or maybe somewhere else. Just find it on your calculator. Make sure you're using a scientific calculator. If you're using like a regular old young calculator, you probably might not even see it at all. So I'm going to do that. Enter into my calculator. My calculator, when I click the inverse cos button, it automatically opens a bracket up for me. So I'm just going to put 8 divided by 11. If it doesn't open up a bracket for you, you could open up one for yourself and put 8 divided by 11. Or you could put the multiplication sign. You just have to remember I really do think you should put it in brackets first because you want to divide 8 by 11 first before you multiply by your cos inverse. So click on your cos inverse button, open up brackets, and put 8 divided by 11 in your calculator, and you should get, so theta should equal 43.3 degrees. So this point right here is that's your answer. We're going to do another example. Here we have another example and we're finding theta again. So in order to do this, we have to label our graph. The longest part, hypotenuse. This is the opposite from our theta, so we have opposite and we have adjacent. The formula that can work, because we don't know what our hypotenuse is, we know our opposite and our adjacent, would be our tangent formula. So we have tan theta, and we're going to make that equal. Tan is SOH CAH TOA, so it's opposite over adjacent, which is 3.7 over 2.7. Okay, and now we are going to do the inverse of tan. So it's going to be tan inverse multiplied by 3.7 over 2.7. Again, grab our calculator. We're going to take tan. We're going to multiply 3.7 divided by 2.7. And our theta should be about 54. Because it's 53.8, but I rounded up to 54 degrees. So this would be theta. we found theta. So just figure out what formula, what ratio you're using, what trig ratio you're using, and then plug in your numbers into there. If you're finding theta, you're going to do inverse of that, and then you should be good. So now, for the next couple of questions, we are going to do finding sides with this SOH CAH TOA. So I'm going to do something that's very similar to what we just did, but instead we're going to find the sides. So we're going to have this. We're going to be given our theta, which is going to be 54.3 degrees. Now, Pythagorean theorem is usually used to find the sides of a triangle. But you need at least two sides in order to use the Pythagorean theorem formula. Right? You need at least two sides. But in this question, we're only given one side and an angle. So how do we find the sides? And you might be asked to find all sides or just find x. In this question, we're going to do find all sides because it's going to incorporate both. You can use SOH CAH TOA to find all sides of this question. Because again, like I said earlier, your Pythagorean theorem, you only can use that if you have two sides of your triangle. In this case, we only have one side, which is our opposite side, by the way, because we're going to label. That's the first step. This is theta. Though you don't see the theta sign, but it's an angle that has already been given to us. We already know what theta is, but now we want to find the sides. That angle is theta, so this is going to be our opposite. And that's going to be our adjacent. So now we're going to figure out what formula do you want to use. So which one do you want to solve first? Do you want to find your hypotenuse side first or your adjacent first? Whichever one you decide to start with, doesn't matter. I'm going to start with my adjacent first this time. And to do that, we're going to have to use our tangent theta because that incorporates both our opposite and our adjacent, right? So our tangent theta, we're going to use opposite first over adjacent, x. Okay, now we have to solve for this. We're not going to use inverse tan because we know what theta is. We do know what theta is. So our theta is, in this case, 54.3. We know what theta is, so we're not going to use our inverse tan. We only use that when we're finding theta, when we're finding the angle. But this case, we're finding the side, so we're going to keep it as tan 554.3. But now we're going to have to isolate x because we are looking for x, which is our adjacent. So we're going to have to isolate that. And in order to do that, you're going to have to multiply x by both. You're going to have to multiply x to both sides to get rid of it here and put it here. And now it looks kind of confusing because I feel like the first thing that comes into people's mind is you want to try and leave x here. So do I multiply 3.7 or do I leave 3.7? No, you're going to multiply x from both sides and put it here. And then you're like, whoa, that doesn't look like we're isolating x at all. But we'll get there. Let's do that first. We're going to multiply x from both sides. This is going to cancel out. So we're going to be left with x tan 54.3 equals 3.7. Right? Now, it doesn't look like we isolated x at all. But we're going to go ahead again to divide both sides by tan 54.3. So we're going to multiply tangent 54.3 from this side and divide that from this side as well. And what's going to happen is this is going to cancel this out. So we're going to be left with x equals 3.7 over tan 54.3. So now we're going to plug this into our calculator. So the next question that I probably will be getting right now is how do I put this into my calculator? You're just going to put it exactly how you see it on this page. So we're going to put 3.7 first. Then we're going to put our division sign. Then we're going to hit the tan button. Not the inverse tan this time, just the tan. Mine opens up a bracket for me, but if yours doesn't open up a bracket for yourself or put a multiplication sign, usually I like to use the brackets. Then we're going to do 54.3 close bracket and the equal sign. So x is going to equal 2.65. I'm just going to do 2.7. And our adjacent right here is 2.7. So we already found that side. So now we know what our adjacent is. Now we could decide to use Pythagorean to find our hypotenuse, or we could still use SOH CAH TOA to find our hypotenuse. And because I want to practice with SOH CAH TOA a lot in this video, we're going to use SOH CAH TOA this time to find our hypotenuse. So now we have adjacent. Now we're going to want to find our hypotenuse. You could now decide to use SOH or CAH. So it depends which one you want to use. I personally would advise that you use sine this time, or your SOH. And here's why. You could decide to use your CAH as well, because now we know what our adjacent is and we're trying to find our hypotenuse, so that would work. But I would say use your SOH because your 3.7 was given to you in your equation. So you know that you're not going to really like make too much mistakes, except you make a mistake while you're solving. But if you use your 2.7, and let's say you got it wrong here. Let's say for some reason you did something wrong throughout your solving, and this answer was supposed to be 3.7, but you put 2.7 down. Now your hypotenuse is bound to be wrong as well, because you got your adjacent wrong. If you use the CAH, if you use your cos, right? But we know that 3.7 is given to us. So I know that is correct. That would always be correct. So, because that was what they gave me in the equation. So I can use my cos with a little bit more confidence that I have a chance of getting my hypotenuse right. It doesn't mean that if you decide to use CAH, you get it wrong. You might have done it. You might have solved for your adjacent really well, and you're good to go. But I would just advise to be on the safe side. Use whatever was given to you in your equation. In this case, our opposite was given to us, so I'm going to use sine. So sine 54.3 would be equal to opposite of our hypotenuse, which is 3.7 over, we're going to make that y since we already used x. Again, we're going to do the same thing on this side. So I went ahead to solve this off camera. So we did the exact same thing I did for this side, but this time we're plugging in sine instead of tangent into the calculator, and our final answer was 4.6. Now we've solved for everything on the triangle. So now I'm gonna do another example, because I really want to show there's a step that I want to do differently here, depending on the example that I do. Okay, so here's another example. Beware that your graph might be turned or twisted. Don't get it confused. It's still gonna be labeled the same way. So here we have hypotenuse. Again, this side is opposite, and then we have adjacent. Now we're gonna figure out what side we want to solve first. So I'm gonna do. What should I do first? We're going to do opposite first this time. So, and then the formula that has both hypotenuse and opposite is our sine formula. So, our SOH, right? That's opposite and hypotenuse. Then we're going to do sine theta. Ooh, not sine theta. You know what theta is? So, it's 43.3. Then we're going to do, that's going to equal opposite, which is unknown. So, we're going to do x over hypotenuse. Now, the difference, if you notice, is that our x this time is on the top and not on the bottom. So, in this example that looks really, really messy, we all the time our x was at the bottom. You see here, our x is at the bottom. Even here for this one, our x or our y, we use y this time, is at the bottom. But now our x is at the top. So what we're finding is at the top. So how do we solve it? So it's pretty much the same thing, except this time we're going to skip one step. So we're going to want x to be alone. So this time we're going to take away, we're going to multiply 11 on both sides. So we're going to be left with 11 multiply sine 43.3 equals to x. We don't need to divide sine from both sides again. Like, there's no need for that because our x is already isolated. So you have to kind of think about that. You want your x to be alone, our x is alone, right? So now we're going to plug this exactly as it is again into the calculator. This time around, we're going to have 11. There's not going to be any division sign. We're going to hit the sign button and put 43.3. Now, final answer is x is going to equal 7.5 or 8. So we're just going to round that up to 8 because I like whole numbers usually. So 8, so our opposite would be 8, or 7.5, whichever your instructor tells you. Now we're going to have to find adjacent. Again, you can use, actually we're going to use Pythagorean theorem this time just to prove that you can use that. Again, we have a squared plus b squared, b squared equals c squared. So we have that. So now we are going to put our a, we could make our a 8 squared plus, we don't know what our b is, equals our c is 11 squared. So 8 times 8 is 64. Plus b squared, 121. We're going to take away 64 from both sides. And then I'm just going to bring this up here. Then our b squared is going to equal 57. We have to square root both sides. And our b is equal to 7.5. Or 8 again. As well. So our adjacent is also 8. So now we are done finding all the sides of this question. So I hope you guys learned something from this. If you're stuck, go back, watch the videos again, and I will see you guys in the next one. Bye.